When you have a factory or factories with multiple production lines producing a different mix of products in different days, weeks, and months, how do you measure and compare their performances in a way that is neutral and fair regardless of the different products? OEE. It's a universal algorithm that is used to measure performance of manufacturing operations. Same as EAF, Energy Availability Factor, for power utilities, and GDP, Gross Domestic Product, for measuring country performances. Some production lines and factories simply use tons produced, cases produced, or pallets produced. This is a very blunt instrument for managing factory performance, as these simple metrics are affected by product mixes for different production periods. Let's take GDP as a widely used example in economics. It was first developed by Simon Kuznets for a 1934 US Congress report, which became the main tool for measuring countries' economy after the Bretton Woods Conference in 1944. It is defined as the sum of gross value added by all resident producers in the economy, plus any product taxes less subsidies not included in the valuation of output. Once this standard algorithm is used in any country, normalized with a single currency, we can now be able to compare economic performances of diverse countries anywhere in the world. In a similar vein, OEE was invented in the 1960s by the Japanese pioneer Seiichi Nakajima and was first written about in a book in 1989 called TPM, Total Productive Maintenance. OEE is expressed as a percentage from 0 to 100, where an OEE score of 100% equals the manufacturing unit operating at full capacity. It creates a single currency and a global standard algorithm to benchmark diverse production lines and diverse factories. It breaks down the production losses into three levers, namely availability, productivity, and quality yield rate. Let's make an example with a production line with a capacity to produce 10 units per minute. A day is 24 hours, or 24 times 60 minutes, which is 1,440 minutes. Therefore, this machine has a maximum theoretical limit of producing 14,400 units per day. That's if you use every minute of the 24-hour day to produce good product without any interruption. The first production loss is utilization loss, where you only plan to run the machine during the day for 12 hours, and you lose the other 12 hours of the day. So you get a utilization rate of 12 over 24, which is 50%. This loss is costly, but not as costly as other losses that we'll be discussing, because there's no extra labor to be paid to produce for the night shift. However, the cost is that management costs and factory overheads have to be spread over only 50% of the used production capacity. Utilization is largely driven by demand from the product in the marketplace versus the size of the machine that you invested on. It is therefore a lever that management uses to respond to sudden increases in demand to extend the shift from 8 hours to 12 hours. In some cases, we'll decide to add the second shift, therefore 16 hours, or utilization of 16 over 24 hours, which is 67%. And in worst cases, put a third shift and run 24 hours, and hence 24 over 24, which is 100% capacity utilization. This reduces the product unit costs as a result of fixed production overheads. The second category of production losses is availability loss. These are production losses that happen during the time that production is planned and production team is present, paid for, but not able to produce. These are due to machine breakdowns, could be finished raw materials, could be a lack of utilities, example electricity, water, steam, gas. Availability loss is a more expensive loss than the utilization loss, in the sense that production labor, supervisors, management, and overheads will be paid without the production taking place. Availability is generally managed at higher levels of the organization, i.e. the preventative maintenance strategy, the material logistics and supply chain strategy, the use of fuel redundancy, e.g. purchase of diesel generators to accommodate stoppages of electricity shortages. The third category is productivity loss. These are small stops and starts, running the machines lower, starting late after the breaks, products jamming for a few seconds, minor setups to get the machine going, and delays caused by the operations team. This category is largely a function of competent shop floor supervision team and a competent and motivated operations team, i.e. on time after lunch breaks. This loss costs the same as the availability loss in the sense that all labor resources plus overheads are paid for in full and yet there is no production. The fourth category of production losses is quality loss. This happens when you produce product that gets rejected for not meeting the quality standard. This is the most expensive loss category because all labor resources, operators, shift supervisors, and management are paid to produce this waste as an availability and productivity loss. But there are additional costs that are raw material and energy used to produce the rejects. It becomes an extra cost. Secondly, there are additional costs to process the rejects, i.e. dispose them, transport them to dump sites, and pay dumping fees. Quality performance is driven by senior management. They facilitate quality risk assessments, design the quality assurance and control program, and continuously monitor quality failures and feedback to enhance the quality controls in a process of elimination and root cause analysis. OEE, however, only takes into account the last three categories of production losses: availability, production rate, quality rate, and does not factor in capacity utilization rate, which is the least costly of the losses. Let's look at the practical implementation of an OEE performance measuring system. With an available 1,440 minutes to produce in the 24 hours, management has decided on 8 hours per day of production. Note that employees are actually at work from 8 to 5, which is 9 hours, but due to 2 of 15-minute tea breaks plus a 30-minute lunch break, the employees work and are paid for only 8 hours for this day, which is 480 minutes. Therefore, utilization becomes 480 minutes divided by 1,440 minutes, which calculates to 33%. In the same example, if we add machine stoppages, in this case 6 of the 9 hours, there were machine stoppages logged, either due to breakdowns or raw material shortages, and the last 2 hours were completely off, i.e. 60 minutes lost each hour, possibly stage 2 load shedding. This all in total takes 195 minutes of losses, so the production line was available to produce for only 285 minutes. And that ratio of 285 minutes by 480 minutes is availability and is at 59% in this case. Now to work on productivity, we look at the actual production output at the end of the shift. In this example, it's 2,638 units. But because the machine rate is 10 units per minute, the standard, and the machine was available for 285 minutes, the production line should have produced 285 times 10, which is 2,850 units. So the ratio between what was actually produced and what should have been produced is productivity. In this example, is 2,638 divided by 2,850, which is 93%. On quality rate, looking at all the products produced for the shift, which is 2,638. In this example, 93 units were rejected, and therefore, good quality product produced was only 2,638 less 96, which is 2,542. And the ratio of good product to total product is the quality yield rate. In this case, is 2,542 divided by 2,638. This is 96%. So OEE is availability rate times production times quality rate, which in this example is 59% times 93% times 96%, which is equal to 53%. 53% is a dismal performance. But if you look at the components, the team productivity was actually 93% when all the resources to produce were available. A lot of production was lost on matters outside of the production team direct area of control. There were machine breakdowns, plus they ran out of raw material, plus the 2 hours of load shedding. This is what makes this measure so powerful. It's the ability to split these three components and address them separately in order to achieve the ultimate goal of world-class manufacturing. To maximize production output per line or per shift or per factory, before making decisions to invest on capital program, you need to look at OEE percentage together with the fourth lever, utilization, and make sure that all these 4 levers are maximized before embarking on capex expansion. Remember, utilization was 33% as a result of only operating 8 of the 24 hours. So if you are struggling to meet volume demand, you can simply increase utilization by working extended shifts of 12 hours. Then utilization increases to just less than 50%, taking into account lunch stops. With this option, you can double your output of 2,638 units to about 5,200 at the current OEE of 53%. But you pay dearly in terms of the extra labor hours and increased overtime rates. The best resort is to increase OEE and minimize utilization, such that utilization is the next resort once OEE is maximized. Then, once both OEE and utilization have been maximized, you can go and justify to the shareholders capex to buy the bigger and faster machine. In conclusion, it is therefore clear that OEE in conjunction with utilization is a tool that can be used across the organization by operators, maintenance, supervisors, production managers, company directors, shareholders, as it exposes the 4 key levers that can increase production output using lowest cost options. So if you, for example, look at 24-month trend of OEE improvement graph, you should be able to observe what of the 3 elements of OEE contributed to the increase and which elements still have opportunities for improvement. And the 4th element being utilization can be looked at separately. On the case of availability, it can be further broken down into machine downtime categories, and those downtime reasons can be dealt with accordingly as a subset of your OEE. Thank you.